Hi, this presentation is going to be fairly basic. I'm going to immediately run through an example and then cover some details that I glossed over. And I'm planning to leave quite a bit of time at the end so that people can ask questions about possible use cases. I think that's actually pretty valuable. So, as you know, access to our cluster is based on SSH. SSHFS is built on top of SSH, and just to reiterate some points here, these are the things we like about SSH. So it's very general and it's very secure, and it actually has a better reputation than most other remote access mechanisms. So I thought I'd mention a couple things on here that'll come up later in the talk. One is that since SSH is encrypted, it can easily be slow, especially over secure networks. So for instance, within our clusters, networking is very fast and it's also secure. So using SSHFS within the cluster doesn't make that much sense. Another interesting fact is that because SSHFS and other SSH uses are going through user-level processes, they tend to be serialized. And what that means is that if you're doing multiple transfers with SSHFS, they will compete with each other. Another negative point is just that SSH can be complicated for a novice. It usually involves config files, programs to generate keys, programs to install keys, editing files, things like that. So SFTP is actually what SSHFS is based on. A lot of people have actually used SFTP. It's very common to use PuTTY, for instance, which has an SFTP-based two-panel file browser. A lot of people think of this as sort of the normal way you interact with our file systems, and it works. SSHFS, I find, is much more convenient because it gives you the entire remote file system as if it was a local file system. This is a bit of a trick because normally to do that would require your system understanding and having a shared protocol with the remote file system. So SSHFS uses layers on top of SSH and uses Fuse, which is actually available on Linux, Mac OS, and Windows. It's quite easy to use on Mac OS and Linux. It's slightly harder to use under Windows. So I'm just going to jump right into the simplest possible example. This is the simplest possible responsible example, and I'll mention what I mean by that. So first, you generate a dedicated SSH key. It's important that this be dedicated. It really shouldn't be the same key as you use. If you've never used a key before, this might be mind expanding for you, but it's definitely a good thing to learn. It's important to modify the key for appropriate constraints. Then you install it and use it. I'll just run through these very quickly. So on my system, which is Linux, I just use SSH keygen to generate a key. And there are a few things to notice here. First of all, I've named it appropriately so I can keep track of what it is. I'm going to call this SSHFS test. The -p parameter is actually the passphrase. So I'm doing something that's very specific to the use case I'm describing here. Normally, when you generate a key that you're going to use to authenticate to a remote system, it's really critical that you have a passphrase that encrypts the private part. I'll discuss that later on. And -c just means that I put a comment in the key itself to make it identifiable. Then I modify the key, and the parts that I'm modifying are actually this here, this the from and command, and this is really essential. The string that comes after that, the SSH-RSA and a bunch of letters, all of that is the actual key, and this prefix, which I think of as constraints, it's really important to modify the key so that it's constrained to be used for only this purpose. And in this case, I've modified the key so it can only be used for SFTP and also only from my workstation. So this syntax says from, and then the IP address of my workstation, and then command, and then gives the full path to the SFTP server command. So this syntax is actually quite flexible. The from can be host names as well, and it can be subnets. So for instance, this happens to be a McMaster University IP address. I could actually have portions of this with star, for instance. So McMaster has 130.113 star.star. That would make this key usable from any machine on McMaster. So then I install the key. I'm using the SSH copy ID command. This is a handy script that's bundled with most distributions of OpenSSH. So it'll be on the OpenSSH that you're using on a Mac or Linux. And if you use OpenSSH, Microsoft's SSH on Windows, it'll also be there for that. This just says copy the identity file, which is the public key, to graham.computecanada.ca. So in other words, I modified, so it's going to copy the public part, which I've modified. And then I can just SSHFS. I guess one thing I didn't mention here is that, yes, I definitely should have said this. I have a config file entry that looks like this. This is a bit messy. So SSH, when it runs, reads a config file. And the config file offers a lot of interesting customizations. And one customization you can do is you can invent your own sort of symbolic host names. So I've created one called Gray SSHFS. And I've told it that when I use that as a symbolic host name in a command such as this SSHFS, what I really mean is this host name, which is the fully spelled out one, and I want it to use the given identity file, and I want it to only use that identity file. So I could actually do all of these parameters explicitly, and maybe I will modify the slides to do that. What it would mean is that the command would look more like SSHFS -o identity file. And then the remote host name would actually be the fully spelled out thing. So Gray DTN1.ComputeCanada. And then the same thing as the parameter where I want to mount it. I guess I should also say, I use SSHFS a lot, so I usually have all of the clusters mounted. And I use this syntax just to make things slightly simpler. So in my home directory, I have a subdirectory called mount. And in there, I have subdirectories for each of the clusters, so that I can have Beluga, Graham, Niagara, etc., all mounted at once. That's just naming, though. It's totally up to you. So that's basically how it all works, and I'm just going to fill in some of the blanks here. I glossed over what SSH actually does, and I think that there are probably enough people attending that I should describe some of this a little bit. There's actually a previous presentation that I made a couple of years ago that goes into some of these details as well. So SSHFS is based on public key. That means that there's a private part and a public part. A public part is what you put on remote machines, and the private part is sort of what you might think of as the actual key. The protocol actually consists of these 4 steps, usually. And it's important to note that these steps happen in order. So the first thing that happens is that the hosts authenticate each other. And you may, the first time you connect to a machine, you may see some comments from SSH about something being missing from a known hosts file and whether you should add it. That's what's happening in that first step. In the second step, which is not normally used when you're connecting to a remote machine, is something called host-based trust. All the clusters are set up with this host-based trust, and it's the way that you can get from one login node to another, or one login node to a compute node. Then there's public key authentication, and as a last step, sort of a last gasp, password authentication. Passwords aren't really deprecated, but I wish they would be, because public keys make things a lot simpler. So the important thing to note about the public key is that the private part is like a password, except that it can't be guessed. And that's one of the reasons that we like it. We have constantly tens of thousands of attackers on the internet contacting our machines, trying to guess usernames and passwords. But they can't do that with SSH keys, because the key itself is hundreds of bits, and it's just not possible to guess. But if you do lose the private part, you leave it on a machine you give to someone, someone breaks into your machine and steals it, you put it on an insecure server, such as a shared departmental server, anyone who gets that key owns access. So normally we advise everyone to use encrypted private keys. What that means is that when you start to use it, you're asked for a passphrase that decrypts the private key, then the private key is used for authentication. So the passphrase has nothing to do with the authentication, it's just unlocking the private part of the key. Normally when people do this, they have an SSH agent, so that, maybe the first time you use a key in the morning, it asks you for your passphrase, and then you can use that passphrase without use the private key without the passphrase for the rest of the day. Encrypted private keys don't work well, they don't work at all, with forms of automation. So they're interactive, they're asking you for a thing, which means that you can't use them when you've got a cron job, for instance, and you can't use it in a batch job context as well. Just a little warning. So I mentioned this earlier. The authorized keys file is how SSH is configured with the public parts. So essentially you're configuring the lock into which the private key will function like a key to open access. On your cluster account, you can create a .ssh directory with an authorized keys file within that. It's textual. It just consists of a bunch of lines. You can actually put in comments as well. Each of the lines is sort of like a stanza in the sense that it contains certain parts. The prefix, such as from and command, I showed earlier, and then the key itself and optional comment at the end, which is free-form text. There are actually other constraints as well, in addition to from and command, that have to do with the other ways an SSH connection can be used, such as port forwarding, for instance. It might be wise to turn some of those off. So just a little comment about how we think of the clusters with respect to this capability. So my example, I was using an SSH key to set up an SSHFS connection between my workstation and the cluster, just to give me convenient access to storage on the cluster. In principle, you could use SSHFS within a job or on the login node for it to access data on the outside. So in the example I'm thinking of, you might have a elaborate project that's built on Compute Canada that might have a portal that runs in our cloud and a VM, and it can access data on the cluster. And you could also do the reverse, which is you could put data in the cloud and access it from the cluster. Now, there are some reasons that this is not entirely desirable. So when something's running on the cluster, we really want the jobs to be compute bound. We don't want them waiting on external resources. And it can be the case that if you're trying to do I/O from an external entity, your jobs would wind up running inefficiently just because they're bottlenecked on that I/O. So that's the thing to be aware of if you try to do this. We do make exceptions. For instance, license managers often have to access external servers. We have ways to do that involve opening a ticket, requesting specific IP and port combinations, and then we set up a hole in our firewall that gets natted. In principle, you could do that with SSHFS as well. So you could provide SSH access from compute nodes outward. I'm not sure how well that would go over. It's probably possible. But you can also do SSHFS both within the cluster, cross clusters, etc. SSHFS performance is surprisingly good considering how much work it's doing. So I did some recent testing of this. We've actually tightened the SSH configuration quite a bit so that nowadays we don't support any of the weaker encryption methods that used to provide fast access. And in fact, if you just do naive things like copying cross clusters with SSHFS, you can get as little as 4 megabytes per second for something that's geo-distributed. So for instance, between Graham and Cedar. From my workstation, which has a gigabit campus connection, I was able to get 40 megabytes per second to any of the clusters, which kind of surprised me. That's pretty good, I think, and that's what you should probably aim for. In principle, there's no reason why you shouldn't be able to get up to 100 megabytes per second. If I test just SSH itself, streaming a single large transfer, I can normally get about 111 megabytes per second in most of these cases. So the 40 megabyte per second is about what you would expect for cluster to cloud transfers as well. So in that scenario I described where you might have a portal that is mounting a file system from a cluster, you could expect about 40 megabytes per second as a pretty good transfer speed. I just added this to mention that SSHFS has this feature called proxy jump, which allows you to make multi-stage SSH connections, and there's no reason that can't be combined with SSHFS as well. So in any circumstance, if you can obtain SSH connectivity, that means you can also obtain file system connectivity, although it may involve multiple jumps. And that's my last slide.